Hi guys, I'm Asif Ali and you're watching CGHOW video. Today I'm creating this full course of UE5 Niagara. For the beginner, I will cover all the basic things that you require to know before starting real-time VFX in UE5, before learning this Niagara in UE5. So let's open Apple Launcher and open the UE5. Current version is UE 5.0.2 and I'll open this project. So I show you this window, current project, and you can create a new project blank. You can add starter content if you want, but I will not. And let's create that on desktop. This is course and just G5 Niagara course and just hit create. Now you have this empty project open. Okay, so first of all, if you don't know, you have this empty map and you can create different type of things, but like this open world map, basic map, and blank map. So let's just use this basic map. It's not saved, so you can just save it here. You can create a new folder, map, and then inside that you can call it my map 1. So in the map you have this my map 1, so I'll just go to new, and when I open this it will show me this. Okay, then here in the content I will create a new folder where I can create my Niagara. You can call it FX, you can call it particles, you can call it effects or Niagara or just systems. So depending on what you want to rename it. Okay, like systems. Then here if you right click you have lots of things, and here you can create Niagara system. Before UE5 here it was particle system for cascade, and to create the Niagara system if you are in UE4 still you need to go to FX, then you can create Niagara emitter or system or other Niagara things. But in UE5 you have Niagara system here. So when you take this, it shows you some options whether you want to select the emitter or create copy from something or create an empty system. So if you just next, it has some presets, some templates. So the favorite one I use the fountain, although it has also empty if you want to start from empty, but I have this fountain also. Let's take this empty, just add it. You can add 2 emitters also, multiple emitters, but I have added empty. It shows you here. Then just finish. Then you can rename it, and you can start with NS Niagara system or just the P underscore, that is particle, and this is my test 1. Okay, this is how you create, and then you can open this by double clicking and you can adjust this window. And this is not the default window UI. If you go here in the windows and you can use the default editor, and now you can see I have to press Control and space to use this content browser. I can dock it, and if I open my Niagara, it looks like this. My viewport is here and this is my settings, but I have, you can just drag it and use it anywhere. So I have my own layout, CGHOW layout. So I will just open that, and I think I have, yeah. So now I have this UI, Windows adjustment. You can adjust according to you. So this is my empty system, and if you right click here and instead of system create the emitter, what is the difference? So let's say you take this fountain and just hit. So you see this is new Niagara system. I open this, it will show you this fountain, but you cannot drag it into the viewport. See, this shows you that red circle with that line. That means it's not prohibited here, it's not allowed here to drag, but my system can be dragged here. So that's why if you create the emitter first, you need to right click and create the system. Or if you have any system, you can just drag your emitter in your system like this. So now I have two emitters here, first my empty and second is fountain. And then you can drag your test here and you will have that fountain. Or you can just right click on your emitter and create the system. So it will create a system, you can drag it into the viewport. And if you open this, it will have just one single emitter that you had here. Okay, so I will delete it. So if you're working, you probably never have to create your emitters like this, but I have shown you how you create, but never you will require that. You can just directly create the system, then use the presets. Or if you don't have anything here, you have empty system, just right click and add, then add, you can add like fountain, you can add like empty or other things like this directional burst. So these are just the presets. Okay, so let's right click and add this empty one. So you can rename it by F2 obviously. So like this is my, you can say sparks, and this is just turn in or turn off. You can right click and isolate it also and turn off here and rename also from. And you can also create the asset from this. Means this is right now under the system, you want to create a separate emitter, just create this and save it here sparks emitter. Hit save and see here you have this sparks emitter, but it will not be, cannot be dragged here because this is system. So again you need to create the system, or you can just drag it into any of your system. It has already that. Okay, that is linked. Here you can see the parent, and you can also go to here and delete the parent, remove parent. So if you will remove parent, that sign will go. Okay, so now you can drag here. Okay, so right click, add emitter and empty, and you can call it like sparks. So what is inside it? Currently you cannot see any particle because we don't have. So first, to see the particle, we need to have the particle, and to have the particle, you need to spawn them, and to spawn them, you need to come to the emitter update, click on that plus icon. You have lots of modules, but it suggests you what it should be there. So we should have here emitter spawn, or maybe spawn burst or rate. So if you take the rate, it is currently 0, and if you put some value here, it will spawn 10 particles per second, but these all 10 particles are spawning on each other. Okay, so that's why you can see just one, but these are 10 particles. You can see total particle count here. Okay, and why it is stopped at 50? Because if you go to the here emitter update, and you will see here it is linked, this state is linked with system, and system has a 5 duration. So if you have 5-second duration and per second you are spawning 10 particles, that means you have total 50 particles. So what else we can do now? We can use a location, so you can see these particles will spawn on a random position. And to do that, you can simply go to the particle spawn, because once they have spawned on the particle spawn, you can click here and it will show you in suggestions shape location, but you can also type here. Okay, so in before UE5 we have different type of save locations separately here, but in UE5 we have just one location, and under that we have multiple shape locations. So if you take this, you can see currently we have sphere primitive, and you can see particle spawning on the sphere, and here you can use like cylinder or maybe cone or ring. Okay, so after this I'm just showing you the basic things first, then we will cover step by step. So now you know how to spawn particle. Now you know how to use the shape location, and then we need to change the color of particle. So in the initialized particle, there is everything you need to change initially for the particles, like life. If I make it like 0.1, you can see they are just spawning and dying. So I can make it 1. After life, we have color that is unset, but you can directly set it and change the color like red or green. After color, we have the sprite size that is also unset. You can use uniform, maybe 10, maybe 1, maybe 50, or you can randomize these, maybe 1 and 50. So some will be smaller, some will be bigger. After this, we need to uh, add some velocity there. So after the shape, we can click here again and it will show you in suggestion velocity, but you can type also velocity. And same if you are working UE4, there will be different type of velocity here. But if you are working UE5, it will show you just velocity, and under that you have 2-3 types of velocity. Like if I add, fix this if shows you any error. And then here you can see under velocity mode, we have 3 types: linear, point, cone. So in the linear, we will have just an axis, X, Y, Z, and you can see by default in Z we have 50. So these particles going up. If I make it 0 or make it minus 50, the particle will go down because of minus Z. Similarly, you can make it on X, particle going on X, or maybe Y. You can randomize things by clicking on arrow. We will connect those parameters with anything, and wherever you see these arrow in these all modules, like in shape you have these, in initialize we have these. So wherever you see these arrows, you can connect or edit or randomize those parameters. So like I want to randomize it, so I can just type uniform. You can randomize vector, you can randomize float, integer, anything, color. So like we will find this random range vector, and you will see minimum and maximum. So if I make the Z 50, particle going up, but some particle will stay there because minimum value is 0. And if you make it minus 50, so some particle going up, some going down, some in between, some are just stay there. So random value from minus 50 to 50. And you can do that in each axis like this. The particle will move on all direction. Okay. So you can, with these arrow, you can reset it to the default. Similarly, here we have by default size here for the random, but if you have uniform like 50, with this arrow, you can randomize. And now you can see we have minimum maximum again. So 50 and 1, you can see. Okay. So basically what a particle system required to spawn particle, then give the life to the particle. So we are spawning it here, we have life here in initialize, then color it, so we have color, then size your particle, we have size here, then location where you want to spawn your particle, we are spawning on a circle, then we want some velocity, we want to push them, so we have velocity, linear velocity, and then they are dying because of the life. So that's it, the main thing to create a particle system. Okay, and here in the renderer we have sprite. Currently these are sprites, these are camera facing planers, so that's what you call sprite. But here in the plus you have other render also, like we can add mesh, we can add light, we can add geometry cache render, we can add ribbon, lots of things are there. So now I will delete it, and we will right click here and add a fountain. So in this fountain we have already spawn rate, velocity, shape, gravity, drag, color, everything we have here. You can see that fountain. We can delete this, delete this. I can drag it here. You can see that fountain. can put it on 0. Okay, so now what is this system and what is this? So basically every emitter you have here, like you can duplicate this fountain. You can see Control C and Control V, or you can just simply Control D, so it will duplicate. Okay, so we have two fountains and we have this system. So this is for the system setting, or you can use it as a common module for both. Like if you make this, you want to, let's move it aside first. So in the shape location, under the transformation, we have offset. Let me turn this on and let's move it on the X, maybe 100. So now you can see both fountains. So currently we have 90 and 90 spawn rate for each. If I make it this 10, you can see the difference. The right one is now 10, and let me offset it even more, maybe 200. Now you can see the difference in spawn rate. So I want to change both spawn rate together with a single parameter, like if you have 10 emitters. So what you can do, you can click here, go to make and make it system parameter. So you will see system spawn rate, and in the system you will find here, or you can just shows you error. So what you can do, select this, and in the parameters here, if you don't have that, you can take that from here, parameters, and type. You have the system rate and you can drag it here in the spawn. Okay, and why is showing? Oh, error is gone. And now you can make it 90. So it is 90. If you make it 0, it is 0, because this is just linked with the left, this one, the first one. But what you can do, you can copy this and paste it here. So now this single parameter connected with both, if you make it like 1000, this is for both. If you make it 1, this is for both. If you make it 10, for both. Make it 100 for both. So this is how you use this to make an instance parameter. You can use it for anything. And if you create a user parameter, this is also reflect here. What is user parameter? I'll show you. So I'll delete this and also reset these both. And in this, I'll go to this arrow and make, and instead of system, I will make it user parameter. This shows you user spawn rate. And in here in the system, if the user parameter will go here, you have this, you can make it 100. And what is the benefit of this? Although you can connect this with both, copy and paste, and now it is controlling the both like we using the system. But the benefit is, if you're dragging into the viewport and select your particle system here, let me delete this system, it will reflect here. Okay, so you can see the spawn rate, you can make it 1 or 100. So now if you duplicate your system here, like alt and drag, you have two particle systems. So in this one you can make it like 5, and in this one you can make it like 500. So you created just one particle system here in the content browser, but it's behaving differently here in the viewport. It has low particle spawn rate, it has high particle spawn rate, and this is just particle spawn rate. You can do anything. You can change the color, you can change the behavior, you can do almost anything with user parameter. So just create one and use it in multiple things. So user parameter is very useful. So now you got to know the basic of how to use this system. Okay, and then I'll just delete this, and also I'll delete the user parameter. We have this 100. So if you go to the property, first we have this local. What is local? So let me delete this. You have this fountain, and if I move this, You can see particles are behaving like a trail when I'm moving it. So it just keep spawning particle and they're behaving like a trail. But if I make this local and if I move, you see they are not behaving like a trail. The whole system, particle system, moving with the emitter. So this is, if you want your particle to stick with your object or character, then you can use that local. Then what is determinism? Determinism is if you don't want your particle to randomize, you want the same thing, you can use that. In this example, you will not see the difference, but I will cover it later. After that, we have the sim target that is currently CPU. You can make it GPU, but before that, you need to click on the fixed bound, which is how much area it should use for GPU. Then you can make it GPU. And currently you will not see any difference, but you can now use a lot of particles. Okay, so this particle system working on your GPU, but you cannot use light with GPU particle system. So there are lots of things you cannot do with CPU or GPU. So, but they have different advantages. So I'm just resetting it and making the particle spawn rate 100. So after this, we have this emitter summary, and this is new thing in UE5. I don't use it much, but I'll show you how to use it. Like if you have a lots of thing in your emitter and you are working somewhere, so you want to just give your FX to other guy who will use that. So it will be very tough to understand all the emitter, all the modules, what they are doing. So if you just want like this, your particle system is finished and user who will use that particle system just required to change some parameters of the important parameters like the spawn rate. So you just need to, which parameter you want to edit, you need to right click on that and show in summary. Okay, so if you click on here, now you have a spawn rate. And what is the benefit? You see this arrow here, you can just click on here and your emitter will be like resize, minimize, and you can just check that important value that you have, like you have this spawn rate, or maybe you have like the alpha of this. So this is the alpha, so you can do that, and now it is reflect here. So now you have minimized your system, your emitter, but the important values are there. You can increase the spawn rate, you can decrease the alpha like this. So this is you can do. Okay, so I will just open it again and just click on here, so it will not reflect there. So now this is empty. Okay, so after this we have this emitter spawn, nothing is there right now. Then we have emitter update, and in this we have two things. We have the life cycle, scalability. So what is life cycle and what is the self? So if you make this system, it will connect here. So now you can adjust here. And what is the benefit of that? If you have multiple emitters, you want to just use the instance life cycle in a one place, then you can use the system. If you want to use that differently, like separately with each emitter, then you use self. Similarly for scalability, but for now, what is this life cycle? So you have the loop behavior. I'm just showing you the important values what you require to know first, although you can explore more settings in it here, in here. So currently we have loop 2 and behavior is infinite. So if you make this infinite once, your particle will just spawn for 2 seconds, then stop. You can make it like 1 or make it like 5. So particle will spawn for that duration, then stop, because loop is once. You can use multiple times. So like loop duration is 1, multiple is 1. It will take 1 second. If you make it 2, it will take 2 seconds, because the loop duration will repeat 2 times, and then you can make it infinite. Okay, so this is the difference. Then comes to the scalability. So in the scalability, you can use itself, otherwise it will take this system, but we want to use that here. Self, it has different options, like if you turn this on, you have these. I will just reset these. So if you turn this on, you have this setting. If I go back the camera, nothing is happening because the range is very high. And also if you want to use that for spawn rate, like if I make it like 200, see the particle gone. If I go closer, particle there. If I'm going back, particle are just ending. So this is LOD. If you want to use that, like if you use 2000 here, you can go back little bit more. Now they are finishing. So in a game, like you have hundred of particle system and just want to use the you want to see the closer one, you can use this. So like here, I go back. So basically now you can duplicate it lots of time like this. See, we have lots of particle system, but we can see only this closer one, and then the next one, and then the next one. And when we go here, similar will happen there. So we can see these, then these, then these. So this is LOD, you can use that. See, this is very useful. So I'll just delete these because I'm gonna stop the LOD. So then it will make it see in the heavy. So this is the distance, then this is the curve how they should finish, and you can use the different setting like kill immediately. Like if you use the kill immediately, see they will kill, and if you will use that kill but after finishing particle. So you can use these things. So this is the basic how you use, but I have already a separate tutorial on LODs in UE4. That is the same in UE5 also. You can use that for the detailed thing, but for the basic one, you need to know where this exists, this setting. So you can use it from here. Then we have the spawn rate. So currently we have a spawn rate and how many types of spawning we have in Niagara. So if I delete this and here in spawning we have these. Spawn burst, spawn from other emitters per frame, per unit and rate. We have already seen the rate. Let's use the spawn burst. So if I make it 100, it will spawn all 100 particle on just first frame. Okay, and if you don't have this infinite, you have once, it will just spawn once and just die. Okay, so let's make it default. So this is useful if you want to burst something. Okay, then in the spawn count we have also time if you want to delay it. Currently it's spawning first frame, but you want to add some delay, so it will take 2 seconds and then it will spawn. We have this one, so you need to increase it. And see, here's a key. You can use that or you can move this key manually. So we can add here. So particle will spawn here. Okay. And you can also add multiple keys. So like particle are spawning here. You want to spawn here also. So just add one key more. And you see we have 2 spawn burst. And like one key more. We have 3 spawn burst. And now particle will spawn 3 times. 1, 2, 3. And these 3 spawn bursts have different spawn time. It has 0.99, it has 2, it has 3 because I set these keys. Okay, I'll set this. Then we have spawn probability. So probability is 1, that means all 100 particles will spawn. If you make it like 0.5, 50% of this means the 50 particle will spawn. See, you can make it 1 or you can make it 1. Okay, then after spawn burst, we have spawn particle from other emitter. That is a kind of advanced thing. I'll show you later. Then we have spawn frame and these both are same, but this works per distance and this work per frame. This is very accurate actually, but these work like same. So if you take the unit, nothing will be visible here unless you move your particle. So it spawn on how your emitter is moving that according to distance. So if you decrease this spacing like 5, it will spawn more particles because we have this decreasing the spacing like zero point 0.1. See how many particles spawning. So this is also very useful if your particle is linked something animated like a sword, like character's hand or foot. So whenever the animation will happen, the particle will spawn. Okay. And similarly, you have the frame, but it is actually slightly different from unit. It spawn the particle, but per frame. It is like a spawn rate. Sorry, excuse me if I just compare these both. So these both, but this per frame is like a spawn rate. Spawn rate works per second, but spawn per frame works per frame. So this is very accurate. It's like it's spawning one particle per frame. And if you have 30 frame per second, then it will spawn 30 particle per second. Okay. And I'll use now spawn rate 100. So we have seen the basics of properties, basic of summary, and seen the life cycle, scalability, and all the spawn emitters. After spawn emitters, we have initialized particle. So first of all, we have lifetime in initialized particle, and this is currently random. I can use it direct. So we have just one life. You can make it 0.5. So all the particle will die on the same age. You can make it 0.1. You can randomize it like 0.1 and 5. So some will go until the 5. Some will die 0.1. So you can just randomize. And minimum maximum means just some will take this value, some will take this value, and some will take in between. So it's not like some will take 0.5, some will take 0.1 and 5. They are not just two values, they are lots of values in between. So like if you take 0.1 to 1, so there will be like hundreds of value in between. Some will take 0.11, some will take 0.123, depending on what randomize it does here. Okay, so let's make it 1 1 for now. After that we have color, and let me just do one thing before I'm changing these initialize system. My background is this scene, so particle is not visible properly. So what you can do, go here, open the preview setting, and in here open the environment and turn this off and make the scene little darker so you can see your particle properly. And here in the show you can turn off the grid and you can check the particle count and other thing, but I will turn this off also. Now you can see your particle system properly. So back to the initialized particle, and we have seen the life. So after that we can change the color. What we can do here, we can put the values here. So if I want to use the green, or we can just change color from here. And if you want randomization in color, you can do that, but you can also use the alpha here. Okay. So if you want to do randomization, you can open this and use the last one, random hue. It will show you 4 parameters. Hue that has some value, that's why particle are randomized. If you make it 0 0, it's still red. If you make it like -1, it will take all the values of RGB. Okay, after the hue we have saturation. So this is like 1 1 is complete saturation. If you make it 0, some will be white, completely desaturated, some will be 1. If you make it 5, some will be too much saturated. You can see that. So let's make it 1 1. After saturation we have range. how bright they are. And if you open this, this is the range. If you make it 10, these will glow. So you can do that here, but you can randomize like 1 to 100. So some will glow, some will not. If you make it in negative, you can see the difference here. Some are not glowing, some are glowing. You can make it 1 1. After this, we have alpha that is here also, but we can randomize. So if you make it 1, all particle is 0.1, but here you can make it 0.1 to 1. So some particle will have low alpha, some will have default alpha. So this is what you can do in initialize particle. After that, we have position offset. You need to turn this on, and you can do also that in shape location, but here also. So if you want your particle to shift here, you can do that. Negative. Okay, so this is the offset. After that has mask, not required for now, but you can use that random value. So if you have grabbed another thing, it will work on that, but not required much. You can just unset it, it's not required. Yeah. So then we have sprite size, and we have lots of thing here. Four thing actually. You can unset it. Then you can use uniform, a single size for all particles, 50 or 1, all the same size. If you want to randomize, you can use random uniform. So like some are 1, some are 20, random size, but still they are circle because this is uniform size. After that, we have non-uniform size. It will show you the X and Y difference. So you can increase the one axis. You can see the difference. See? And if you want to do the randomization of this also, you can do that. So X minimum maximum, Y minimum maximum. So you can stretch this. So some X will stretch, some will not much. Okay. After that, we have sprite rotation, and it is random, and you can see that when I stretch the particle like here, you can see the random, they are random aligned. Like if I make it, if I use it unset, you can see they have all the same rotation, and because I was using random, they have random rotation. Instead of random, you can use direct angle or normalize. What is difference? If you use angle, it will go from 0 to 360. So if you want to rotate it 90-degree, you need to put the 90 here, or 45-degree, you need to put the 45. So 360-degree it takes. And normalized angle takes 0 to 1. So if you want 90-degree, you need to put 0.25. Or if you want 45-degree, divided by 2. That's the difference. Okay, you can use the randomization. Then UV mode, I'll show you. Actually, to use that, you need to use a different type of texture. That's how you can see that. So let's use that. So because we were learning the initialized particle, we are just about to end this, but in between we are creating our material. So to create material in UE5, you need to right click and create a material. And if you want to use a texture, you can import that texture from outside from your computer. So let's create a material, and you can name it M anything, M spark, M radial. Okay, and here first you select it, and there are the blending option. I want to use like translucent and unlit, and maybe two-sided. Then we need to add something here. There are lots of nodes. We can use this radial exponent. If you connect it here, it is radial. So if I use this material, it is the same like this. So we cannot see that UV mode. So what we need to do that to change the UV mode, I'll show you. So if you have this, and if I just change the position of the center, because it shows you vector 2, you need to take this, press 2 on your keyboard and left mouse button, and see this is here on the left corner. Okay, and just save it, browse this, and here in the sprite renderer, use it. And I'll just reset this to uniform. Let's make 100. And randomization, just set this. So all the circles are on the left corner, like in my particle system. If you want them to randomize, take the left or right, you can use the UV mode. So if I use the random X, some will be right, some will be left. So basically this is flipping it like this, left, flipping it to the right. And if you want to use it on Y, it will flip it vertically. So it was left up, it will be left down. So some will be left up, some will be left down. And you can just use it X and Y. So it will take all the corners randomly. And if you just want not random, you just want it from left to right, that's it. So you can just use this custom and just make the X -1. So all will be right from left. So all the particle will flip from left to right like this. No randomization. So this is how you can use this. Then the one more thing I want to clear here, we were using this alpha to make it more transparent, but currently our alpha is 0.1 and they are not transparent. If I make it 0, nothing else, nothing will reflect here. Even my color is not changing. So why? So whenever you create a material for particle, I'll delete this. You need to take the particle color, and if this RGB connected here, it will change the color in the particle, and if this is connected here, it will change the opacity in particle. But we are not using radial, it is just a square. But if I save this, make the, you can see the difference. Now we can use the alpha, we can use the color, but this is square. Now you can use this, so you can use it in opacity. You take the multiply and multiply it with the opacity, and we will have that radial. And now you can save it, and now you can see we have that radial. So we were covering our initialized particle and we have checked the UV mode. After that we have mesh, so we will cover it later because we don't have mesh and we don't have ribbon. So these two will cover later. We have covered all the things that required in Sprite. After the initialized particle, basically we will have a location. We will spawn particle somewhere. So we have the sphere location, and I have already shown you how to create that. If you want to check it again, delete this and just take the shape location. I will move it here. So this stacking is work in a flow from top to bottom. So if your location is here, velocity will work from the point. Okay. Sometimes it shows you issue, so you need to work in a flow. Okay. So in the shape location, we have currently using the sphere. And what is the parameter of sphere? First is radius. Let me turn off the velocity. You can delete the velocity or just turn this off here. So any module can be deleted or just turned off with this arrow, this checkbox. And also gravity, I'll turn this off. So particle will stay there. And in initialize, let's use the 10 and make the alpha default. So now you can see particles are spawning on a sphere and they have some life, that is 1. You can increase or decrease that sphere. Okay. And after the radius, we have distribution that is currently random. So that means particle is spawning on that sphere randomly, and you can use direct. So direct U is connected with edge. If you make it like local, now you have just a point and you can use this value. See? So you can change that point and you can randomize this value. So now you have the ring. And similarly, we have the V that is up down. So if you copy this random value here, it is the same thing that we had here random. So on the U we have 0 to 1, on the V we have 0 to 1, that means it is completely random. So we can use it random right now. So then we have one more thing, that is uniform. It will spawn particle on the points of the sphere. So if I increase this, see, they are not random, they are just spawning on the same vertices of that sphere. Okay, so I'll just use it random. So in the random, you can see this is solid sphere, it is filled. If you want to just spawn particle on the surface, we have this sphere surface distribution. If you make it 1, you can see we are just spawning particle on the surface. You can decrease this, just make it 1. Okay. After that, we have the hemisphere distribution x or y. You can make it 0.5. You can see if you want to make it minus 0.5. Doing the same, but if you want to cut it from the top, you can do that. I'll show you how, but right now make it 1, and then this value 0. This value is cutting from the side to side. So this is for side to side, and this is for top to bottom. Okay, and 0.5 is cutting the bottom. I want to cut the top. So what you can do in transform, in rotation, first we have the scale. Let's make it 1. We have a scale. So if you want to scale this sphere on one axis, because radius is for all axes, if you want to scale it on x, you can do that, or maybe z, you can do that. It's a flat disk because z is 0. So this is the scaling. After this we have rotation. So if you use this raw and yaw pitch and roll, and if I make this 0.5, we have this bottom gone. So we can rotate this like this. So we have now top gone. Because I have rotated it, we can rotate the sphere at my location. After rotation, we have scale, we have rotation, we have offset. We need to use it default, then we can offset. And this is the same thing that we have in initialize here, position offset. So you can also offset it here. Okay, up, down. Okay, so we have cleared all the main thing in sphere, and almost the same thing you will find in anything. Like if you have cylinder, these things will change, but these things will be same. So like we have cylinder height, we have cylinder radius, and then the midpoint. Because if I'm changing the height, you can see height is changing from the center. If you make it 0, height will change from the this point. If you make it 1, height will change from the this point. See. Then same thing, surface, you can spawn particle on the surface only. It's kinda not working properly. Yeah, now it's working. Okay, then we have again the same Hamming circle. So if you use this, so you can see this is cutted, or you can use the X. It is cutting the X. And then we have lathe, that is very useful. If you use the lathe, we will have a curve, and you can see we can modify our cylinder. So basically this curve is 0 means top, 1 means the last key means the bottom, in between will take the in between, and you can change those. See, you can change those. You can make lots of good things with this. You can put more keys by clicking middle mouse, and you can add it. This is very useful in some case. And then this transform is same in any shape location. Then we have torus. In the torus, basically we have torus, and first we have torus radius, then the handle radius, how the tube is, how thick is, and then random distribution. That is the same thing. We can use direct, and we need to reset these. Also make it local. So we can use this value. We can randomize this. So it will be again a ring. After that, we will have in the torus, under torus, we have knot also. And the knot, we have some parameter like how many rings are there. Okay. And this is the same thing. So we have also box location, and we can just make it flat. So we have X, Y, and Z size. If you make the Z 0, we have just flat planar. And same thing, the midpoint. So if it is 100 and I'm using it like this way, if you make this 0, it will scale from the bottom for the all axis. Okay, so same thing. In the box we have by default planar, so it doesn't have Z, it has X and Y, but you can use the same box. Then we have ring that works like a torus. It doesn't have that handle radius, but it has this radius and it's just a circle, and we can also use the hexagon. Okay. Then we have the cone, the last one. So it has the cone shape. This is the cone length, then angle, how spread it is, then inner angle, radial. These are adjusted default. Basically, if I just use this is making that flat, because if you turn this off, you can see this is roundish. If I increase this, you can see this is roundish. If you flat this, it will just cut this top, so it is flat. Okay, so these are the same transform. So I'll just use a sphere again and the same default settings. Okay, so we have a default sphere. After that, we have velocity. I'll just delete it and take the again. And currently we have the linear velocity, and if I play, particle going up because of this default value, you can make it 200, and you can use the different axes. And this scale is just multiplier. So if you have like 100 here, and if you want to just multiply it by 2, it will be double, it will double that. And why it is useful? It is useful if you are using random values. So you have like 100 minus 100, and now you want to double these both, you can just make it 2 or 5. Okay, so you don't need to type minus 200 200 here or minus 500. You can just double the all the values which you have here. Okay, then one more thing I would like to clear here, like if you have like 100 velocity and you have just here this emitter, and you rotate this emitter, velocity is now in this axis. And why? My emitter is not local space, but still, why? Because in the velocity is local. You need to make it world, so it will always go up the particle whether you have rotation or not. Okay, so you can use that. So then after the linear, we have point velocity. It will work from the center, from all direction like this. And you can also randomize this like 0 to 500. Some will go fast, some will go slow. Okay, and then it has also offset. So you don't want to use that from the center, you want from the bottom, so you can make it like minus 100. See, now it works from here. And then we have the cone velocity. In the cone velocity, we have this strength first. Let's make it 500. It's going there because the cone axis is X. You can make it Z. They are going on Z, but slightly in a conical angle. You can increase the angle like this. So if I turn off my shape location, you can see that better. So you can make it 10, 20, 50, 100. You can increase that angle. Okay, so these are the basic thing in velocity, and let's use the linear for now. Turn on the sphere, use it maybe 200. After the velocity, let's come here and let's use the forces. So I'll delete this and all these modules. So after you have velocity, if you click here and go to the forces, we have lots of forces, but I will cover some basic ones. So like you have gravity, you can type directly gravity, that is a force, and this is minus 980. So particles are going up, but they are also falling. They are going up, then they are falling. See? So in gravity, you can just use these axes, like in any axis you want to work, and they will fall on that axis. It just have three x, y, and z, three parameters that you can put the value and it will work. After gravity, what you will require vortex. So we have vortex force and velocity. Let's use vortex velocity. So I'll just use like 100. And then in vortex velocity, we have this amount. If you increase it too much, you can see particles are rotating. And they are rotating on z-axis. If I want to rotate on x-axis, I can do that. Or y-axis, I can do that. So it has just a strength or axis. Okay. So then we have also curl noise, very useful. So in curl noise, first we have strength. Let's make it like 1000. You can see particles are behaving randomly. Then we have frequency, that noise pattern scale. So that curl noise, every curl noise have some noise. So you can scale that noise with this frequency value. If you decrease this like 1, the scale will be bigger, like 5. But that noise is same always. If you want to animate that noise also, you can use the pan noise. You can put the random value in all three axes and it will pan that. You can see the difference. If I use the 2, you can see. And if I use the 50 by default, so you can just adjust the frequency. If you will put the lower value, the scalar will be bigger, and the higher values, the noise will be smaller. And this is the strength. Then you can animate these axes. So it has other parameter also, but these three are the basic and the most useful thing that you will need to use. Okay. Other thing you have here in the forces that is very useful, that is drag. So like if you have a loss of velocity and particles are going very fast in a direction, and if you will increase that drag too much, particle will stop. But you can use also a curve here. So if you use this curve, so initially drag is 0, but at the end drag is 1, and let's make this like 20. So particles are going very fast, but when they are about to die, the drag is very high, that they are stopping. So similarly, I use this curve here. You can use the curve in anything. Okay, like color, like the size, anything. You just need to click on that arrow, and you can uniform it, or you can use the curve. You can link it with anything. Okay, so I'll just drag this. Sorry, delete this. After this, what is useful in forces? We have covered curl noise, gravity. We have this point attractor that works like point velocity. So if I just turn off the velocity, and this is the point attractor, if I increase the value, turn off the fall off, particles are attracting to the center point, and the center point is simulation position, and you can just make the value of attraction negative, so particle will spread from the point. And this is the radius, in which radius this should work. Okay, then what is, there are other things that we will cover in our coming things. We will create something. So one last thing we can use here, that is inherit velocity. So how it works, like you have this velocity 100 or 200, and this inherent velocity doing nothing here. But if you move, let me just, if you move your emitter, see, particle are just pushing on that direction where I'm moving my emitter. See, so you can increase this. You can just make it float. If you want to increase three axes altogether, you can convert the vector to the float and then just increase it. Like if I make it 10, nothing is happening until I move this. See, and you can also make it negative, like -2. It will work accordingly. Okay, so very useful if your particle is attached with something animated. So next thing is, so basically we had this initialized particle where we change the life, color, size initially. But what if we want to animate those our life? So what we can do, we can use that here in update. So we have this stack, everything that will happen initially we will put here, everything that should happen continuously throughout the life will work here in the particle update. So let me decrease the spawn rate, maybe 200. So now we have a size. Let's make the size, this is the 10, and I want to, let's decrease the spawn rate even more, maybe 50, and make the size maybe 50. So we have these size. And if you want to animate these size, so what you can do in here, particle update, just type the size. We have the mesh size also, we have sprite size. Because we are working currently on sprite, let's use the sprite scale, and it comes with a curve, so you can see the result. Because the curve is down, this is 0, this is time, this is value. So at the time 0 means initially size is 0, you can see. At the time of, because this is normalized age, so this will work from 0 to y. It doesn't matter your life is 10 or 20. The 1 means at the end of your life. Okay, 0 means at the starting of your birth. So at the end of your life, the size is 1. But you want invert of that, there are little presets here. You can use this. See, the size of the particle initially is 1 and at the end it is 0. So they are smoothly just scaling down. And you can also use this curve. So they are scaling up, then they're scaling down, smoothly coming and going. So these are the curve which you can use. You can also use non-uniform values or non-uniform curves. So we have now X and Y different curves. You can check it here. We have different curves. Okay. So let's say if you want to use these different curves, let's say I want to use the X, like I want to increase the X like 10. Okay. But I want to decrease the Y. I want 1 initially and then 0 at the end. See, they are making the stretching on X but decreasing the size on Y when they are dying. So you can use these things also. After that, in initialized particle, we had the color, that is initial color. But what if you want to use the curve in the alpha or color? So here in the particle update, you can, if you have something color in initialize and you want to edit that color, then you will take the scale color. So in that scale color, your color will be same that you had in initial, and you can use like this alpha. You can use a curve here and see the particle are fading, or you can use this so they are start fading and fading out. Similarly, if you want your particle to brighter, you can make this float and then again use a curve here. So you want in between your particle little brighter, maybe 20. So here your particle will be brighter. Okay, so this is how you use. But what if you don't want to use this initial color, you want your color to animate, like you want red in the starting, green in the end, then you don't need that. You will take the color here. And when you will take the color here, it will override the initial color. See, we have the red color here, but it will show you the white color because we are using the color here. Then we can make it, of course, red. And if you want color over life, you can click here and make the color from curve. And you will have this new color gradient. And you can just click on that. This is your initial color. This is your the last color of the life. So if you click here, double click, and you want to make that red, you can see initial color is red. And then you can double click on this, and the last color when they are dying is green. You can put lots of swatches like here in between. You can make this blue in between, and you can add as much as you want. And similarly, we have these two swatches for opacity. So the top one are for color, the bottom one for the opacity. Initially your opacity is 1, and at the end your opacity is 0. You can make it also 1, so you can see they are opaque here also. And initially you can make this 0, so particle will like this. And you can add in between that, you can make it 1, and then you can make these two. Sometimes it has issue to selecting. Now there is fade in, fade out. So we have edited our our color, our size, and now we will edit our rotation. So I'll delete this, we have this. And to check the rotation, we need to stretch them on one axis because this is a ring, circle, we cannot see the rotation. So I'll use non-uniform size, and now we have this rotation. So now click here, type the rate, you will find the sprite rotation under the orientation. And this is connected by default with delta time, so you just need to add some value like 200, and it will rotate on the same axis, on the same positive axis. And if you want some particle to rotate on the different, like these are rotating clockwise, you want to rotate them like anti-clockwise, you can make it negative, or you can make this randomized, so you can use minus 200, 200. Some will rotate clockwise, some not. Okay, so next is we have clear all these things here. I'll just make the size uniform. Here we have this solve force velocity, and this is very useful if you're using force or velocity. Otherwise there will be particle movement. It is required if you want to add any forces. Like if I delete this and I add gravity, fix this, it will again spawn that. Because for the forces or anything, you require that forces and velocity module. So it is default. If you don't have any, don't worry, just put any forces, it will work. Or you can just type here and it will show you that module. You can take that. After that, we have this last thing, render. And by default, we have a sprite render. First, we will check what we can change here. Then we will try other render. Okay. So first in the sprite render, we have the material. We can use any material we have in our content browser. Then we have the source. We are using the particle. To apply that material, we can also use the emitter. Okay, we will have just one particle here because of the emitter. We can use the particle. Then the main thing is here now the pivot. And why is useful? The pivot is very useful because like you don't have velocity or gravity. Okay, and let's say you have rate like 200. Particle are rotating, you cannot see that. But if you offset the pivot, now you can see. And what is happening here, let me show you. So this is your particle and the pivot is here and this particle is rotating. So you cannot see because this is just a radial. But if you have this particle at the pivot you are offsetting here, so this will rotate from this point, so it will rotate like this around this point. And if you put that pivot here, your particle will rotate around this point, this point. So you can edit that point through these. So 0.5 means it is in center, and if you put some value, it is different. Okay, you can use X or Y. So this is what it is. Then we have sorting that we use. So if we have lots of particle overlapping each other and have some issues, you can use these ascending or descending. We will work on that when we will create some effect. Okay. Then sub UV. What is sub UV? So let me show you. If you have any texture, like I import a texture from here, like I have this texture 10 by 10 explosion. I'll import this. And if I open this, this is explosion 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 by 10. So you need to make a material from this. So you can right click on that texture, create a material, or just create a separate material and then drag your texture. So this is my M explosion. Open. And then you can drag it into your texture. Sorry, material, or you can just press T and left mouse button, then you can browse your texture from the content browser. Okay, after that you can connect it directly here, but we will use the particle color also. Every time you use a material for particle, use this node, whether you use opacity or color in your particle or not. But sometimes you can avoid it, but you have to be used to of it. So I'll multiply this main thing and connect it here, and then multiply the alpha and connect it here. And how I know the alpha is there, you can open your texture and see this is showing you transparent grid, and you can also check from here. So it has this alpha, it has the R, it has the G, B and alpha. If this alpha is white, then it doesn't have alpha, but you can see the difference, black and white alpha. So we have this, and I'll make this translucent and unlit and two-sided. So let it compile. You have this explosion material. Let's save this. Browse this material, and in your particles, in the sprite, you need to use that material. And when you are using a sub UV material, you need to come here sub UV and type the frames. You can see it's showing you all 10 frames. You need to type 10 by 10. And if your frames are in sequence that will be play, then you need to use this. If your frames are random, then don't use it. So I'm using it, and let's reset the pivot also. I'm deleting the shape location and velocity. And now I have just a point of particles. Let's delete it actually, or you can use the same rate, maybe 120. Okay, let's add a velocity. So these are going up, but I cannot see anything like an explosion. And why is that? Because we have put the 10 by 10 here, so that means it's just taking the first frame. It's not playing that sub UV. So for that, in the particle update, type the animation, and you will find this sub UV animation. And the first frame is 0 and last frame is 100, but we are also counting the 0, so last frame will be 99. Okay, I'll delete that rate for now, and also reset the color. You can see that now, but still we cannot see properly, so I'll make the life maybe 4 and velocity maybe from point. Now you can see this explosion is animating. And there's also something that's making it very weird. Go to the setting, project setting, and search here auto exposure, turn this off. Now you can see my explosion is animating. So this is how, if you have fire sub UV, smoke sub UV, or anything, you can use it like this. So now instead of spawn rate, we can use spawn burst, maybe 20 particles, and see we have that explosion. We can reduce the strength and also like 5. This is how we use. Okay. So in the sprite render, next thing is visibility, render visibility, that we will cover later. Then we can see the binding. And how useful is this? This is very useful. I'll show you how. Then we have cutout, and I'll show you the why is cutout is very useful. So let's say instead of burst, you have a spawn rate again, and this is 20. And you have dragged your particle here. This is very small, but okay. See the difference. Your explosion size and the overall particle size. So that is very expensive if you use in game. So what you can do, I have to. You can use cutout image to cut the empty area. So how you will use that? Go to sprite render, go down. And if you want to use the texture from material, you can tick here. Otherwise, you can take that texture from here. If you tick here, it will use the same texture. Okay, and what you want to use, I want to use alpha from the texture, and now you will see it's trying to manage the free space. So it is for like optimizing your effect. These are the values how much you want to cut. See, it is now almost cutting that space, but it will also show you sometime edge, cutting edge, so use that value carefully. Okay, after that we have sorting. I'll show you how it works. So like you have two emitters, this one, and I'll just copy this, Control D, and in this one let's make this red. Now see, both are like overlapping each other. I want my red to be on the top, and currently we have this sorting 0 in both, and I know this one is my red, so I can make it 1, so it will be on above of that one. Okay, so this is sorting. This is like a Photoshop layers, which layer is above, which is down. Okay, so this is useful for sorting. Okay, and then here one thing we left here in here, that is short mode. So you can also use it like ascending. So you will see the particle when they are dying, they will be above. You cannot see particle where they are spawning. If you use the descending, you will see they are spawning from that point, and when they are dying, they are going back. So you see that spawning particle in front of you, and then dying particle going back. So ascending means dying particle coming forward and spawning particle going backward. Okay, and then you can also use depth or distance. Okay, so we have covered almost all things. Now the binding. How useful is this? So like color is bind with the color, velocity is bind with the velocity, sprite size bind with the sprite size. You want to create your own module and you want to bind it with here. So what you can do, let's say you had this color, and if I change that color to green, my color is green. If you make it red, it is red. But if you don't take this color, you take a module, a different module, like from very down here, you can create set new or existing parameter, and then create a linear color, and you can rename it anything like my color, and it is not using anywhere. You can change this color, it will not reflect on your particle. Okay, unless you will bind that my color here. Okay, and why is useful, I'll show you again. So like in this one particle system, and you have like you want to use two things together, like you want to use this my color and you want to also use color. So what you will do, you can drag it here and take the color, and now this color will change the color, of course. But if you take the LERP, I hope you know the LERP. What is this? So LERP works is like if you have the LERP factor 0, it will use the 1 from these two. If it is 1, it is use the different value, the other one. And in between use the blend of these two. So now you have two color and you link the first color with my color. And my color is pink and the second color is green. So if I make it a 1, this is taking green. If I make it 0, it is making pink. So this is how also you can use this custom colors. So I think a basic thing I have covered, and next thing we will use different renderers, then we will create something and use it in like a game. So delete this and create a fountain again. So you can see that fountain. So now I can delete that sprite renderer and I can take the mesh renderer. Nothing is there because you need to use a mesh here. We don't have any mesh. So you can import that. So I'll just import, and from desktop I have lots of mesh like this hemisphere. You can just import it with a material or you can avoid that material. So we have this hemisphere that I created in Maya. So like if you have any mesh, you can just select, let me turn this off, select that mesh, go to the particle in the mesh renderer and click on that icon, or you can just find it on the source content browser. So you can see the behavior and everything says same, but we have a mesh renderer right now instead of a sprite. So what will change? Nothing will change in the properties or summary or states on spawn rate. Everything will be same. Initialize life will be same, color will work same, but the sprite size we don't require now. We will require this mesh size. This is currently unset. You can use it like uniform. You can scale that mesh size like 5 or 20 or 1. And this will work like same like sprite size, but it has like 3 x, y and z, 3 axes. So like if you use non-uniform, you have x, y, z. You can just stretch on z like this. Okay. So you can also use uniform size, random. Some are smaller, some are bigger, or maybe random non-uniform. So there will be too much randomization on separate axes. Then the next thing what comes here, the spawn location, that will be same. Doesn't matter what render you are using, this is the same. Velocity also will not affect with mesh render. But the next thing here, we were using in sprite render random rotation here. But for the mesh, we don't have rotation here. You need to create a module. Click here on the spawn button, type initial mesh orientation. Currently it shows you that random, so every mesh is randomly rotated. If you don't want to rotate it randomly, you can make it none, and then you can turn this on here. And if you want to just rotate it like 90-degree on one axis, like on this axis, like 0.25, this goes from 0 to 5. You can see the 90-degree rotation. You can also randomize these from here. You can put 1 and -1. This will be the same random rotation on every axis. But we have already random here that we can use. So after the initial random rotation, the next thing we were using in sprite render was we were rotating in our life, scaling size our life changing color will be the same, but it doesn't have any material right now. So to create a material for mesh, it is the same process, but you need to like check what your UVs are, so you will apply the texture on that. So you can just create a material M mesh, this material for mesh, and I just want to change the color, so I will just take the particle color and just connect it here. I don't want to use opacity. If you want to, you can connect it here and just make it transparent or additive. I just want to change the color, so I'll just connect it to the base color and emissive and save it. Browse this, and in the particles in the mesh renderer, we had used this mesh, and down here we can use this enable material override. Click on this, click here, open this, and use that material here, M mesh, and it will take a second or 2 seconds to update, and then you can see all the meshes are white. And then you can do the same thing that you did with the sprite render, everything same. So you can use the color here, you can use the curves here. If you want to make them bright over lives, you can use the curve. Like initially I want to use like 10, and then when they are finishing they are becoming darker. You can also edit this curve like this. See, they are becoming darker when they are finishing. Cool. So next thing, we want to update orientation over life and scale this particle over size. So first we want to scale. So you can type the scale here and you will find scale mesh size, that is under the size. It has three vectors, X, Y, and Z, three axes. You can just, because I want to scale all three axes together, you need to make it float and then use the curve. And by default the curve is like this, going down, so you can see particles are just going down the size. You can use any of these curves or maybe this one, so the size will become more and more our life. So this is how you scale it. Then you want to rotate it, so you need to type here update mesh orientation, and here first you need to check the axis. Let's remove the initial rotation first and also the size. So we have just one axis, and in the update orientation you need to choose the axis, then rate. So if I increase it like 10, you can see these are rotating very fast on that axis. And you can also use this axis or maybe y axis, and you can randomize the axis also. So now it will take the every axis and rotate that. See, every axis. And you can also randomize the rotation rate. So some will rotate by 2, some -2. So there will be loss of randomization rotation. Okay. Forces work the same. You can see the gravity is working the same as the sprite. You can use the curl noise, that will also work the same. You can animate the curl noise like this. The next thing, because we have the gravity, and here they are not colliding with the ground, so what we can do, we can use here collision and just check. Now they are colliding with the ground. Okay. One more thing you can do that will be little advanced, but because I'm doing it right now, let me show you. So if you want your particle should stop when they are colliding, because they are still colliding and still moving because of curl noise, you can do one thing. Move the collision above the curl noise. In the curl noise you have strand 2700, so you can just LERP it and put the like 3001, and alpha is 0, 0.5. So if you make it 0, there is no kernel noise. If you make it 1, there is lots of kernel noise. So you can make it boolean, and in boolean you can connect it with a condition has collided. So if the particle is colliding, kernel noise will not work. If they not colliding, kernel noise will work. We need to switch it. Yeah. See, the kernel noise is working, but when they are colliding, kernel noise is not working. But they are bouncing too much. So in the collision, you can make the bounce 0 for now. See, and also you can use the drag same way. So in the kernel noise, you can copy that LERP and paste it here on the drag. But you want drag when they are colliding, so you need to value put here like 20. Let it compile, and when it will come, it's taking too much time because this should be after collision. Because we are using condition, so that should be after collision. See, particles are stopping now. But still they are rotating because we didn't do that thing with rotation. So I will move this also after collision. And same, we have this rotation rate that is random. So I will multiply uniform 2 and minus 2 and then paste that condition here. And this will be like 1. So rotation will be 0 when they are colliding. So everything is conditioned by the collision, rotation, kernel noise, everything. And the life you can make infinite if you want. You can increase the life here, but if you come here in the particle state, you can just turn this off. It doesn't matter how much life is there, life will be infinite. They will never die. Looks cool. So this was my mesh renderer. Next we will cover the ribbon renderer and what we can do there. I will delete that particle system from report and let's turn this off. So this API test is actually p mesh renderer. I'll create another Niagara system and let's take the empty one or and this will be p ribbon. So we have this empty one. We can also use the presets from here. We have this beam, we have mesh. Okay, so we can create a ribbon. So first we need to spawn particles like 100, and then instead of sprite render we will use a ribbon renderer. To check the ribbon we need to have a velocity, so I'll add the velocity. Now you can see that ribbon and how it looks in the viewport. Very small. So in the initialize down here we have the ribbon size. You can just make it direct, maybe 50. You can use that. This is how it works. So we have this ribbon. This is cool thing. And you can use curl noise. So like I have this curl noise, but I just want this curl noise to use like very little value. Okay. And the life, random life doesn't work directly if you make it random. there will be some issue in the ribbon. So better is to just use a direct life, maybe 1 or 2 or 5. Then in the ribbon, you can use the ribbon width, like we use the sprite size or mesh size through curve. You can use scale ribbon width, and you can increase or decrease this, but you can also use the curve. So you can see, let me increase the life or velocity to 100. See the difference. So this is your trail. Okay. And to create a material, you will just create a material M ribbon, and you need to take a texture. You need actually gradient from left to right. So you can use also texture from Photoshop, but I'll use the texture coordinate, pressing U and left mouse button. Then shift C for mask, and if you connect it here, we have this, but we want this white, this black, so you can invert it. Press on your keyboard and left mouse button, and then if you want to fade it even more, press E in your keyboard and left mouse button for power, and you can increase that exponent value, but we have already there. You can make it 3. Then particle color, of course, to change the color, and you can use it directly here and multiply this alpha with opacity, and you can make it translucent or additive unlit, and I will also make it two-sided. Save this. Browse this, and in ribbon you can use that material here, and then you can see the difference. You can change the color directly from here, or if you want to change our life, you can obviously use the color like we use in Sprite. Make this curve, and you can use 2 colors, like initially red, and you can see the difference, and then green. Okay, you can put in between swatches also, but this is how you create the ribbon. So you can directly link this trail with your projectile in game, and this will work fine. But you can also link it with the particles, and I will show you that also. In the stages, we will use the event handlers. Let me just clear this ribbon, what we can do else. So in here we have also the shape of ribbon. Currently this is planar. You can also use the tube. You can see this is 3D tube, increase the subdivision. So it is a cylinder. You can also use multi-plane. There will be a cross plane, and custom you can use, but yeah, plane is best. Then we have the tessellation. So this is, if I increase the strength, this is moving very smoothly because it has lots of subdivisions, but you can use custom divisions like 2 or 1, or maybe you can just disable this. Okay, so I'll use this automatic for now, and bindings are same, sorting and everything is same here. So this was the basic of ribbon. I'll show you in coming chapters how to link these to make a projectile. Okay, to use the event handler. So I'll just save it for the latter, and next we will use beam. So for the beam, right click, take a Niagara, and we have already a dynamic beam preset that we can use. So select this, add it, and I'll call it P beam. So you can see what is there. We have a beam setup here, and if you want to like do it from scratch, I will delete it and create a empty. In empty, you need to type here beam setup, and you will have beam setup. Then you need to spawn particles like you have from that, and you can see that. But in beam setup, let's move it here. We have the start position and end position. I can increase it, and then we need to also type here update beam, spawn beam. So now you can see the difference. But we have the sprite render, we need to use the beam ribbon, and I will use just the space color. And the beam setup, let's make it 200. So you can see that beam we have like 200 distance from here to here. And you can change the beam width like 520. Yeah, you can see that. You can also use the curve, but you need to connect it with the little advanced. So let's use it like this. So you have this distance, and why beam we use? We use for lots of things like lightning. So if you want to make the lightning, you need to just put some noise here. So like you can use the curl noise, like you have 500, and you can animate it like 5, 2, 2, 1. And if I play, I have this. You can decrease the curl noise frequency, and to remove that smoothness, you can go here in the beam and disable the tessellation. So you can make the lightning like this. You can use the color direct and like this. We can duplicate it, Control D, and just slightly change the frequency. You will have to. So this is the basic how you create the lightning. Although I have lots of tutorials on lightning, how to create it, any type of lightning. Okay, but this is the basic because we are covering the beam. I'll just save it for now. So next we will cover other renderer. I'll take the fountain, and if I open this, you can see we have checked the sprite, ribbon, mesh, and we have these three. So component renderer I will not cache render actually not cover here because I have a very separate tutorial on that specifically for that, and I'll have to create a geometry cache for that if you want to use. But we will cover the component render and light render. So for the light render, let's rename this. This is P light. So like you have the white particles, and if you add a light render here with the light, you can turn off your sprite if you want. So they will be just light but cannot be visible. So here, so you need to turn this on to check. So your light will be connected with each particle. And if you drag this here, you cannot see that light right now. But if you increase the brightness of your particle, let's say you have red particle and you have like too much brightness, then they will be also light, you can see here. So if I increase the size of light, we have the radius of light and the inverse squared fall off. If I turn this off, you can definitely check the light, but we will use that. You can increase the size of light. Okay, but if you want your particle should not be bright but light should be bright, what you can do, you can reset this like 1, and in the light you can put the color value here very high. So see, particle are not bright but light is bright. Let me make the scene little darker. Control L to make the light little darker, and now you can see the difference. And if you have now my particle taking the light is taking the color by itself, but here, turn this on, we have the color binding, that is the particle color. So you can also create your own color. Take the set new existing parameter and take the color, linear color. This is like my light color. And if I make this like green, and in the light, if I use that, you'll see they will be light. Okay, so you can also do that. And if like I connect it just with the color and I don't use it, and I have this red but I have random color, and the strength is like 508, so it will take the random light color also. Okay, so this is how you use the light color. Now the last is component renderer. So how we will use the component renderer is, let's say I create a next Niagara and I have fountain P component, and in this one, instead of sprite, I'll delete it. I'll take the component render, and in this you can almost take anything from your content browser. So if you want to spawn another particle system in this particle system, like okay, my engine is freezes. Let's stop this. So Unreal was crashed, so let me create component render again. Niagara fountain P component. So in this one, we will use component renderer. And what is component renderer? Actually, instead of this, you need to take the component renderer. And you can use almost anything here. So like if you want to spawn another particle system in this, like you want to spawn this light effect or this ribbon effect in this one. So what you can do, you need to search here Niagara, and then you need to put the Niagara effect here, like we want to use this light one. So I'll just browse this, Control B, and then click here. So you can see those particle systems spawning here. And likewise, you can use almost anything like the mesh renderer. Okay, so you can use also beam, you can also use the ribbon, anything, not just the particle system. You can use the skeletal mesh, you can spawn a BP, you can use for audio, landscape, anything. You can see they are almost everything you can spawn. So this is something that you need a separate video that I have already a separate video on the component render, but you can do that. So better is to check that. But yeah, this is the basic what it do. So we have now done all the things. Now we will use the stages, how we use that. So let's create a new Niagara. We have fountain. So P event. So what is these events? Event handler. Event handler is in between two emitters. There is a connection, like one particle should emit from the position of other particle, or one particle should emit where the other particle is dying, so or where the other particle is colliding. So this is the event thing. So like we had this beam, not beam, we had this ribbon. So let's rename this ribbon, and you can just copy this, Control C or right click copy, close this, and we have this event system, and we have this fountain. Let's call this fountain source, and then paste the ribbon here. So we have now two emitter here. You can see first is the source, second is my ribbon, and you can decrease the source spawn rate like 5, and I want my ribbon to follow these particles. So we will use stages now. So first, in the source emitter, you need to go to the property, turn on the persistent ID before using the events. Then because we want to use the other emitter as a trail, that means we want to access the position of these particle source. So in this case, we will generate the location event. After using that generate location event, we will come to the ribbon and then click here and click on the event handler. And in the event handler, we will use the location event from the source and then every spawn particles. And then after this, click here and use the receive location event. Okay. And then we don't need the spawn rate here, but see, we don't have ribbon spawning on there. So for that, we need to put the value here. See, and now you can change the behavior of these particles, like you can increase the velocity or angle, and these trail will just follow. You can increase the spawn rate, it will just follow, doesn't matter. So this is the event handler for location. Let's save this and duplicate it, Control D. And in the event handler 1, we want to use when our particle is dying, there should be other particle. So I will delete that ribbon and we have that source, and let's make the life maybe 0.5 and 1. So they are dying something here. I delete the fade, so they have opaque all the time. And let's say you have this 5 particle. So I want where they are dying, there should be a burst of particles. So first I need to make a burst of particles. So I will duplicate this, Control D, isolate it and rename it burst. And in this burst particles, we need like this burst, like 100 particles. And we also need velocity from point, like this, maybe 100 and 200. And we don't need gravity for now. So we need like a burst like this. Okay. So what we will do here in the source, instead of location generation, we will type here generate death event. So when these particles will die in the burst, we will delete this and take the stage event and use the death event. And again, spawn particle, and you need to type that maybe 10 particle here and then receive death event. That's it. And now see, and delete the burst from here because we are bursting here. So this is like a firework, and you can increase the spawn rate maybe 100. And now what you can do, you can take the ribbon, copy and make paste here. You can use the multiple event. So now in the source we have the death event. We can also generate location, and in the ribbon delete the spawn rate and use the event handler, use the not death location and spawn particle like 1 and see. And we also use receive location. We have particle trails, and I'll delete the curl noise from it, and also velocity. So we have like a firework, a very simple firework. So events are clear, just we need to use the last one, that is collided. So I'll duplicate this event one more time. So we have event 1, and let's make the open this actually, and I will delete the ribbon, and in the source I will delete the location, and I will also delete the death. So these burst particles are not working now because we have deleted this, and I'll drag this event here, and I want when these particles collide to the ground there should be a burst. So what I'll do, oh, I open actually, let me just, okay, it freezes again. Let me, actually I have to open this event too and delete the ribbons from here and drag it here. So what I want, when these particles collide to the ground, then this burst should happen. So first in the source, I will increase the life maybe 5 so they can fall on the ground, and then the gravity, so I will use the collision, and I'll turn off the bounce. So particles are now bouncing and colliding. Okay, not this. Now they are colliding, and I want when they are colliding, particles should spawn. So instead of generate location and death, we need to generate collision. And in the burst, in the event handler, we will use the collision event. But instead of this death event, we will delete, we will use receive collision event. That's it. See, when they are colliding, particles are spawning. So this was the event handler. Okay. So now let's create a static mesh location. So for that, I'll create a Niagara. I'll take the fountain, and this will be my P static mesh location. So currently we have just this hemisphere, but you can use any static mesh that you have. So you see, I'll delete some forces so you can see better. And we have this sphere location, I'll delete that. Instead, I'll take the static mesh location. Fix this, it will spawn one more module. And here you can use your static mesh. You can see it already spawning on that, but particle size is little high. So now you can see that is taking that hemisphere and spawning on that, and instead of that you can use any mesh and it will spawn. So let me show you one more example. If I import a third person, and in this third person we have this character, so I can use this and create a static mesh in the content outside. So we have that static mesh. So now here we can use that character, fix, and see the particle are now spawning on that character. You can increase the spawn rate. So this is how we use static mesh location, and you can do anything with this. You can add velocity, you can add curl noise, any forces you can add like this. Cool. And then we will use skeletal mesh. So for that, let's create a new level, basic one, and in my systems I'll create one more Niagara, and then this will be P skeletal mesh. So I'll delete all these things again, and I'll use skeletal mesh here, and you just need that character skeletal that you want to use, and see it's already spawning. Then if I take the animation here on the viewport, and let's make it little darker, and then you can drag your particle system to the viewport and then connect it to the animation, link it with none, and see it is already spawning on that character. And you can add some velocity, so they are going back, and you can make this GPU, and then use lots of particle like maybe 5,000, and then I will use size with this curve, and also we can add curl noise like 200 maybe. I'll animate this also, maybe this is 20. So see, we have a very nice effect with our character. You can use even more, maybe 30,000. and then decrease the alpha, make it like little like this. And also the size, I'll use the uniform 10, turn off the mask, and now we have this effect. Cool, so we have covered now the static mesh. It is just a location. You can do anything else that you want to do with your effect and it will work the same. Now we will create a basic morph effect to particles. So I will do that. Let me show you. Right click, take a Niagara, and this is my P morph. So you can use static mesh for different shapes. If you want to morph from a character to animal or a shape, you can do that. But for me now, I will use just a basic shape. So let's say I don't have any velocity and I have a shape. So this is like torus. So first shape is torus and I have lots of particles, maybe this much. And I just want to use the burst. So I have this much particles and life is maybe 2, don't have mass, and alpha 0.2. And this is the shape location and I can rename it. So this is my torus, and then I can duplicate it, control D or maybe control C and V, and this will be the second shape will be like what you say, this is sphere or maybe planar. Okay, so you have, if I turn the torus off, this is box, but we can make the z 0. So this is my planar. We can make it 200, 200, and this is, I will rename my plane. So I have two locations and I want to morph between two. So what I will do, if I turn these two, you can see particle are trying to use both. But what I'll do here, take the LERP particle attribute, and in here in the position, turn this on. We have two positions. I want first position my shape location 0. So shape location 0 vector, and the second I want to use shape location 1 vector. Okay, and depending on this value, if I make it 1, this will be planar. If I make it 0, this will be torus. So you can just use the curve from 0 to 1, and that's it. You don't need to do anything, and there is a morph. And you can do like this, like this is at 0.45, this is 1, and 0.6, this is 0. And at the end, at 1, this is 1 again, but at 0.9, this was 0. So they will be like morph. And you can do like if I make it 5 and make the life also 5, and you can use the curl noise and use that curve, same curve, because I want when they are morphing they should be curl noise. So use that curve and paste it here on the strength, and I'll just animate it also. So I want when these are changing means these values they should be curl noise. And so what we will do at these points, let's make all the 0, all value 0. Actually this was 0.45. So these are the keys where my transition is happening. So I want my curl noise in between. So I'll put a key here, and in this key, like I have 1000 curl noise. See, or maybe 10,000, and make it 20. And similarly, let's move these little back. So there is a at point 3 it is 0, but at point 5 it is too much, and at point 7 it is 0. Let me show you. Now you can see it is not working properly. Let me check it first if it's working or not. Yeah, actually the curl noise is not working because of my LERP. So you need to put it here. Now it's working. So now we can paste our curve here, make all values 0, and I want in between curl noise. So here I want like 1000. See? So we have curl noise. But this curl noise is also distorting it, so you can just avoid it for now. So you need to use the here also some values like velocity. So this is the basic thing how you can do that. So this is also for the LERP. So I want also like use the color, and this is color, and this is also color, and I want this color to be red. Sometimes it is hard to select this. See, so every time it will convert to Torus, it will become red, and I don't want to use alpha. This is how you can use morph. So now let's create by using all these things create that we have learned, create a basic fire, and let me save this map also. Map skeletal. Okay, so I'll just take a new label, and in here in content let's create a new folder, fire. And what we can do here, so for fire first we need a material for flames and one material for smoke. So I'll create a material M fire, and in this one we need that texture. So press T and search your texture. I need to use this noise. Then we need to use a radial exponent. We can multiply these together. So if I check this, because this is radial, it will cut that thing. Okay. Then we need to use a panner for panning it, like 0.2, 0.2 or zero point 0.1. Then we can use the texture coordinate pressing U and connect it here. And if you will multiply it, it will work for tiling. Like 0.5 will be bigger scale. So we can use dynamic parameter here. Okay. And then I will use the particle color and multiply it with opacity and use it here and also here. I will make it translucent, unlit, and side. And I will take a dynamic parameter. This is for noise style. And we have this pan, so we can control the panning speed by using time and multiply this time with here and multiply with dynamic parameter. So this will be my pan speed. Okay. And then we can also like distort it. So if I use the power by pressing E here, we can use this exponent to distort it, dissolve it actually. So we have three dynamic parameters. I'll save it. And in here, I will create a Niagara particle system, take a fountain, and this is my free file. And I'll browse this material and I'll use it here. Take the dynamic parameter to set the default values. Noise style will be 1, speed will be 1, dissolve will be 1 for now. And I need, of course, velocity, but I need actually linear velocity. I will use the random, maybe 150. I don't need gravity, or if I use, maybe I can use positively, so it will go up. Then life, I will use 1 and 0.5, very short. And in the dynamic parameter, we can randomize these things, maybe tiling 0.5 to 1.5. And same thing I will do for the panning, copy paste. And for dissolve, if I make it 2, you can see the difference. So I can use the curve here. So it will go from like 1 to 4. So it will dissolve completely. We can use that fire color here like this, and also live 8.6 here. And see, this is popping thing you can use here. You can use this key. So initially I want like 4, and last I want 4, but here I want just 1 and maybe 0.2 or maybe 2. Okay, and velocity is too high, maybe 60 and 50. And you can add little curl noise in it. So for the random behavior, maybe 100 like this. Then you want to add smoke in it. So for that, and also in the gravity, I will use on X maybe 30. So it will slightly decide. And this is my flames. I will control D it, and this will be my smoke. And in the smoke, because I duplicate it, first this will be grayish, and then life will be like 1.8, and scale will be maybe 20 and 10. See, and we can also increase the opacity, maybe 2, life maybe 1.5, and we can also decrease the curl noise by 50. Yeah, and in the flames I will make the shorting 1, so my flame will be above my smoke. Okay, and I will use this hue not for color but the glow. Okay, and in the smoke I want some smoke little darker, so I will use this not for color but the value, so maybe 0.2. And in the alpha maybe 5, some will be darker, minus 0.2. You can see the difference. And yeah, you can increase the velocity and also size maybe 30, 20. Then you need to add the sparks in it. So what you can do, you can duplicate this flame, copy and paste. And you can use the same material if you want, but you can use radial if you want. So I will use the same, but I want to use uh, the size non-uniform, and I want to stretch it on Y, but like 20, 50, and this will be 1 and 5. But I want these to face the velocity. So in the sprite render that will be missed, in the alignment you can use the velocity aligned. Now they are facing the velocity, but need to increase the life maybe 2 and 1.5. and the size may be 2, 10, 2. Like this, and you can use more and more curl noise like this. So you have a basic fire burn. So this is how you create all the elements by duplicating each thing. Now if I place this into the viewport, like if I take this basic, make this little darker, and I place it here. You can add light if you want. And one more thing, the fire is cutting through the ground, so there is a sharp line. To avoid that in the material, you can use the depth fade and just multiply it with the opacity here at the end and just save it. Now it's not cutting. And see, this is my fire, but you can find it through name. But if you want the preview here, we can open this, place this in a center and click on the thumbnail, and there will be fire thumbnail here. Okay, so you can add light, but if you don't want to add light, you want to add glow by Sprite, you can do that. And here we will learn new thing. So I'll copy the flame, paste it here, and this is my glow on the ground. So to add a glow on the ground, what you will do, I don't want velocity or these things. So I have just here the glow, but this is the camera facing. I want it to be ground facing. So in the sprite render, in the alignment, you need to make custom aligned. In the facing, custom vector. Then in the particle spawn, use the align sprite to the mesh orientation. Now this is aligned but on x-axis because here, so you need to make the z-axis. Now this is facing the ground. Okay, but I don't need gravity, also turn this off. And then I want like scale the size, so I will use this and maybe spawn rate 5 and size maybe 50, 50 and 100. So it will spawn like this. So you can see, you can add a fire glow on the ground like this. Okay, you can make it 20 if you want, and you can make it slower, 1.51, and you can decrease the alpha 0.2. So this is how you can align and use, you can fake the light. So all the basic thing I have covered that you need to know to create a basic fire from scratch. If you are very new to the Unreal Engine 5 Niagara, you can now create at least a fire through like a texture and material, and then dynamic parameter that you can use. So the things that I didn't cover in this tutorial, I will keep making separate videos, but I wanted a single video also for all the newcomer who want to learn Unreal Engine 5 Niagara. So that's it. I hope you like this course. If you find it useful, please like, share, comment, and share this video. Thanks for watching. Keep learning, and bye bye.